Hi third year, and welcome to this lesson on addition polymerisation. The prior learning that we need for today's lesson is I can describe what happens in an addition reaction. So we learned about addition reactions when we were thinking about alkenes. Remember, the structural feature of an alkene is that it contains the carbon-to-carbon double bond. Now this is very reactive, so if we add in a diatomic molecule, for example bromine, then what happens is the double bond breaks open. We now have a single bond between the carbon atoms. We still have the same 4 hydrogen atoms surrounding them, but we add in the 2 bromine atoms now too. So that is an addition reaction. It always has something that you start with, let's call it A, with a double bond, and then we have something that we add into it and one product. Okay, so that's addition reactions. Today's learning then, I can state that alkenes can undergo addition polymerisation, and I can understand the difference between monomer, polymer, and repeating unit. So we're going to be discussing these terms today. Okay, so when we're talking about addition polymerisation, the main application of this lesson and this learning is about plastics, okay? The word plastic means to be able to change shape or form. And that's why addition polymers are so useful to us, because they can create plastics of all sorts of different shapes. They can be molded into different sizes for different purposes. We can change their color. We can make them totally transparent. We can make them moldable and flexible, or they can be tougher and stronger if we need them to as well. So loads of applications of plastics. Okay, so when we're talking about making addition polymers, remember that pencil symbol means we're writing this slide down. Many of the plastics that we use in daily life are addition polymers. Okay, addition polymers. They are made from small alkenes that are created during cracking, e.g. ethene and propene. And we just learned that cracking is when we take larger, less useful hydrocarbons and we break them into smaller parts. And every time we break up a larger hydrocarbon into smaller, more useful parts, at least one of the products that we get will be an alkene, something with a carbon-to-carbon double bond, and therefore able to react. Okay, so we've got a new word here to draw our attention to, the word polymer. So if we think about the parts of the words that we're learning, so we've got monomer and polymer, okay? So mono means one and poly means many. Mer just means part, okay? So polymer means made of many parts, okay? So on page 7 of your booklet, you've got a glossary, and you can fill in for polymer a very large molecule formed by the joining of many small molecules called monomers, okay? So then if a polymer is the large molecule, then the monomers are the parts that make it up, okay? So what is the process of polymerization then? That's what we call it when we've got lots of addition reactions happening. The double bond in alkenes such as ethene is very reactive. The carbon-to-carbon double bond can break open, allowing new molecules to add on to the carbon atoms. When many small molecules join together in this way, it is called addition polymerisation. So let's watch this happening. Okay, so imagine that we have a whole heap of ethene molecules. We're only going to demonstrate this through a diagram using 3, but in reality, if you were doing polymerization, there would be millions and millions and millions of these ethene molecules, but we're just going to draw 3 for this, okay? So we've got ethene molecules. Okay, and then the first step is that all those double bonds in the ethene molecules break open. So they break open, and now we've got single bonds between the carbon atoms. So now these carbon atoms are very reactive, because at the moment they've only got 3 bonds, they've only got 3 of their unpaired electrons bonded, but they've got a 4th one, okay? So they're desperate to form another bond here. And what happens is the bonds between the ethene molecules now start to form. So instead of having separate molecules, you now have a huge chain, okay? And what's really happening is that it's the same ethene that we had to start with, but just repeated all the way along. Then instead of having a double bond between them, it bonds across to the other ethene molecules. Okay, so Let's then, in our books, note down what's the monomer, what's the polymer, and what's the repeating unit here. Well, the monomer is the alkene, or the molecule with the double bond that we have to start with. So this is the monomer, okay? So in your books, you can just write example, okay? And so we've got a monomer, that will be the molecule with the carbon-to-carbon double bond. The polymer is the chain, and often we'll see the chain written with these brackets round it. That's just to indicate that it continues on. This is not the full molecule, this is just part of the molecule. So this is the polymer, or truly a section of the polymer, okay? And then here we've got the repeating unit. Okay, so the repeating unit is called repeating unit because it's the part of the molecule that repeats as we move along. Okay, so it's the repeating unit. Okay, so monomer, it's the molecule that we have to start with. It's got the carbon-to-carbon double bond. The polymer, it's what we have at the end, and then when we have a closer look at the polymer, we can see the repeating unit is what is repeated as we move through. Now I'm going to talk to you about how we could change any alkene to make it look like a monomer, okay? And that's called the H-shape representation of monomers. So, in the example that we just talked about, ethene, that was dead easy because we had the carbon-to-carbon double bond sitting on the horizontal and no other carbons, okay? If we have something like propene, okay, so we've got 3 carbons in total, and then we've got the first carbon has 2 hydrogens, the second has 1, and the third has 3. Okay, this works well as a monomer, but the way it looks right now, it's not very clear that it is a monomer. We are looking for it to fill this H shape, okay? And we can make any monomer for addition polymerization fit into this H shape. All we need to do is we need to make the carbon to carbon double bond sit across the middle, okay? And then if this is carbon number 1, and this is carbon number 2, we're just going to draw what is attached to carbon number 1. So that's here. And carbon number 1 has a hydrogen and another hydrogen. Carbon number 2 has a CH3 and a hydrogen. And now that we've drawn it in this H shape, okay, that's the monomer, then we can easily draw its repeating unit. Okay, so it's just very similar, except instead of the double bond, we have a single bond and these hanging bonds. And it's convention to put these brackets around it again to show that this is not a molecule that exists by itself. It's part of something larger. Okay, it's the repeating unit. Okay, and if we were to show a section of the polymer, it's convention to draw where 3 monomers would have been. Okay, so I'm drawing what's on the first and the second carbon, then where another propene would be, I'm drawing what's on the first and the second carbon, then where another propene would have been, what's on the first and what's on the second carbon. And this is a section of the polymer. Now, naming addition polymers is something that we just should be aware of. Okay, it's not super important for the moment, but this would be polypropene, okay, because we started with propene. To work out whether a structure that we're given is a monomer, a repeating unit, or a polymer, we need to look at the structural features. So if the structure we're looking at contains a carbon-to-carbon double bond, then it's a monomer. If it just contains 2 carbons on the horizontal chain, it would be the repeating unit. And if it's got a longer section, usually 6 carbons on the horizontal chain, then it's a section of the polymer. So this says, draw the structures of the polymers formed from the following monomers. Show 3 monomer units linked together. So let's let's look at A. So there's our monomer. We've got the carbon 1 and carbon 2. On carbon 1, I've got hydrogens, and on carbon 2, I've got a chlorine and a hydrogen. And then I'm going to just repeat that. So that would be my repeating unit. And now I'm drawing a larger section of the polymer. Okay, so things I'm checking for. Have I, do I have 3 repeating units shown? Yes. Do I have a single bond hanging on either side? Yes. And then I can put these brackets around to show that I know this is just part of something, not the whole thing. Here's a question that says the structure below shows a section of an addition polymer. Which molecule is used to make this polymer? So all we need to do is look at a section and we need to just say, well, here is the repeating unit. So the monomer would look just like the repeating unit, except instead of having these hanging bonds, it would have a double bond in the middle. So we're looking for one that looks exactly like that, and it is B. Okay, so a recap of that learning. I can state that alkenes can undergo addition polymerization. I can understand the difference between monomer, polymer, and repeating unit.